I think we stop around this, no? That means this is stuff we already covered. I think here onwards. Am I correct? Are you ready to start? Are there any more to come?
Yes, sir, we can start.
Then we'll start, no?
Yes,
Idusam? Shall we start?
okay, sir.
Okay. Uh, so we were discussing about the spanning tree protocol basically. Now you know the purpose of the spanning tree protocol. At the layer 2 level, we want to maintain some redundancy for reliable network or for tolerant network, but it introduces some loops within the network. So to avoid that, there is no there are some loops. Because of that, frames are keep repeating in endless manner. Frames are keep repeating in endless manner. To avoid that situation, we want to have loop-free topology. So to introduce the loop-free topology, there is a particular approach which is called the spanning tree protocol, which runs based on the spanning tree algorithm. So spanning tree algorithm again based on the different mathematical algorithm incorporating together. We didn't discuss that part in this session. Then one another important thing is the particular standards have been introduced by IEEE. Even this part we touch upon last week. So with that, what is happening? Whatever the network with multiple links, physically those are there, but logically we are going to block some ends. If it is blocked like this, no circle here, right? No circle here. Did you get the point?
Yes.
Yeah. So if you have any question, you better raise, right? Then moving forward, so to make that decision, that means block can be either here, that place, here, or here. 4 possible places. So why in this particular case, the particular link is blocked. This is blocked, logically blocked. Why this particular link is chosen? It is based on the cost calculation. So each link, each involvement of each link, and yeah, in involvement of each link from one particular place to the root, right? That is the calculation. In one particular place to the towards root, what is the cost? So calculate that part, then find the shortest path. Find the shortest cost. So shortest cost is active. Every other path are not, paths are not active or blocked. Right? So for that they have assigned some cost. It is based on the speed of the link, 10 gigabit per second to 10 megabit per second. This is the highest and this is the lowest. Once the data speed is little low, then the cost is high, right? Then cost is high. Here it is 100. When the data speed is relatively high or significantly high, 10 Gbps, then cost is low. because it's allow us to forward the more and more frames at one single time. So time wise, we take very less time to transfer frames over such link. Right? Did you get the point? Why we are fixing the numbers like this? For the shortest, for the relatively smaller speeds, we put the higher number. Relatively low speeds, we put the lower numbers. Likewise, numbers are assigned. These things are revising. This is the previous one, not the original one even. Now they have come up with, basically IEEE has introduced this approach, right? So because of the development of technology, these speeds will be changed. Some technologies will be obsolete. Obsolete means they will not be used further, right? Likewise, things are evolving. Based on that, we should consider the actual cost with related to the presently available technology. These are just value, numerical value assigned through the spanning tree protocol, or spanning tree algorithm. So eventually we can change that, right? We can change that because it is happened that it is just manipulated by algorithm to find out the shortest path. So no involvement with the physical uh, physical devices or physical links. It is just based on the calculation is based on the numbers assigned, right? The physical cable strength is considered, right? Physical link related data speed is considered. However, at the end, this calculation is purely based on the algorithm of the spanning tree protocol. So for that, we have to feed numbers. Those numbers are derived by IEEE in this form as one version, right? Even this can be evolved by now. This is little late one. Hope you understood that part, right? We will move forward. If you have any question, please raise it. Right. So with the spanning tree protocol, the root node is important. Root node, right? This one, root node, which is controlling the entire spanning tree. We call it as root bridge as well. This is one compulsory element in the spanning tree. ගහක් නැහැනේ මුලක් නැතුව නේද? මුල තියෙන්න ඕනේ. Root is there. Always root is there. There is a tree. For any tree, there is a root. In the same way, spanning tree also comprises with root node, right? So at the very beginning, actually, it is randomly assigned. This will be the root. This will be the root. After some time, we change, or algorithm change. This should not be the root. This is the root. Then after some time, second one is also not the root. Maybe third one introduced. Because whatever the feeds comes in, allow to execute the algorithm and find the right root, right? So the second point, the spanning tree protocol construct a topology, right? Eventually, spanning tree protocol construct a topology on top of the physical infrastructure. Physical infrastructure represent the topology. Topology is none other than just physical connectivity. Physical connectivity. Then spanning tree protocol construct topology, which is logical topology that has one path for reaching every network node. That is the true meaning behind the tree true meaning behind the tree, there is at least one path. There is actually one path, not at least. There is one path. At least can use can be. There is one path for reaching network nodes, right? The resulting tree originates from the root bridge. So eventually, final synchronous or established tree is introduced with the root bridge. We just say root. It is originated from the root bridge. However, it is also one another node in the network. If that node is disappear, the some other may come and make the or accept the responsibility for the root bridge, right? Moving forward, here it says redundant links that are not part of the shortest path tree are blocked. Then we are going to find the shortest path tree. This is the shortest path tree. So whatever the redundant link out of that shortest path tree are blocked. Those are physically available, but logically not available, blocked. Then after some time, if the presently active link is down, the blocked one will come into picture to contribute for the communication, right? It is because certain paths are blocked that a loop-free topology is possible. It is because certain paths are blocked, right? Some paths are blocked, that loop-free topology is possible. Eventually, it introduced the loop-free topology. Data frames received on the blocked links are dropped, right? So blocked links are not accepting the frames. Actually, not accepting the frames of user traffic. User traffic. There are two kinds of traffic, user and administration. So block one is not accepting the user traffic. It is accepting the administrative traffic. Otherwise, block traffic, block link will be blocked, or block link is blocked forever without popping up as required, because it is not even receiving the administrative traffic. So in that sense, you can simply understand block link even or block port even should accept some kind of traffic, which is the administration traffic, not the user traffic. User traffic means computers and devices are introduced some traffic based on the human interaction. We click on something, then it introduces frames. So such traffics are not accepted through the block link, but to wake up or popping up, in that sense, block packet accept such administrative traffic to notify such changes, right? So spanning tree protocol requires the network device to exchange exchange messages to detect bridging loop. It is obvious. Now root is there. Then how it finalizes with the other part, right? Link that will cause a loop are put into the block state. So that is also understandable by now. Then very important thing, how they are going to communicate. How they are going to communicate. I mean the part of that administrative traffic. Spanning tree protocol introduce some administrative traffic. Those administrative traffics are contributed by BPDU, Bridge Protocol Data Unit. That is the data element introduced by spanning tree protocol specific data unit, right? So the messages a switch sends, allowing the formation of the loop-free logical topology, is called the bridge protocol data unit, right? Bridge protocol data unit. So BPDUs continues to be received on block ports, right? Continue to be received on block ports, right? Such traffics are accepted. This ensures that if an active path or device fails, whatever the present active path or active device fail, a new spanning tree can be calculated. Actually, should be calculated. Otherwise, network is isolated in some form. So to avoid that, we once device or link is failed, we should find an alternative. That is the sole objective of having redundancy, right? So hope you got the idea. BPDUs are important. So now we are going to look into the structure of that. Sorry, what was happening? Structure of the BPDU, right? Root bridge ID, root path cost, sender bridge ID, port ID. So root, we finalize the root first because it is essential for introducing BPDU. It is essential for introducing the BPDU. Root bridge ID is the first thing. Who is the root? Root path cost. That means from the sender's end, here the sender bridge ID, that means another switch. Sender bridge ID means ID of another switch. This is ID of the root switch. Then there is a distance from here to there, whatever sender originated into root, because our reference or base point is the root. What is the distance? It is based on the cost that we assign, cost we discuss. Then the port ID. What port on the sending bridge does this BPDU come from? What ports on sending bridge does this BPDU come from? So senders port ID. Senders port ID. From which port this traffic was generated? Right? Because switch has multiple port, in which port that traffic has been generated. That is the idea. Let's with that understand, we will move forward. Do you have any question, guys? 12 students are there. You guys are asleep now?
No, sir.
No, sir.
Okay, good. Any question? Vikash?
No, sir.
Okay, good. Let's move forward. BPDUs, our data unit for spanning tree protocol or bridge protocol, that is stand for bridge protocol data unit. Yeah, bridge protocol data unit contain enough information so that all switches can do the following. So with the detail available with the particular data unit supporting the spanning tree protocol to synchronize, it is possible to continue whatever it requires for synchronization process. So select a single switch that will act as root of the spanning tree. First step is that select a single switch that will act as, not actual root, act as the root. Root wage inna. That is important, right? At the very beginning, pick a switch which act as root. not the root. At the very beginning, pick one switch as a root. Calculate the shortest path from itself to the root switch. Designated one of the switches as the closet one, that means very much close one to the root. Right? That means designate mean නම් කරනවා. Designate mean නම් කිරනවා. root තියෙනවා. දැන් randomly pick කරගත්ත root කෙනෙක් ඉන්නවා. ඔය කොහෙන් හරි මේක පටන් ගන්න ඕනේ. ඊට පස්සේ root ළඟින්ම තියෙන switch එකේ port එක designated port එක විදියට ගන්නවා. Designate one of the switches as closest one to the root for each LAN segment. Right? Then we just find out the second switch, root switch. The second one is the nearby other switch. This switch is called the designated switch. We assign a name for that. Name is designated switch. Root switch, designated switch. The designated switch handles all communication from that LAN towards the root bridge. Okay, now we have the root, then designated one, then traffic to the root is handled by the designated switch. So if you just try to understand it with analogy, so you can think about the university structure, right? The vice chancellor is the root. Then there is a dean. Then whatever the traffic goes to the dean, typically, right? Actual case it might not be because humans are working on. But if we consider it as computers, those are computers. PC is a computer and dean is a computer, all we are computers. Then we should work through the dean because he is the designated switch, simple terms. Right? So we are not reaching the root. It is not possible to reach the root. Right? In actual networking environment, root is not reachable without having without going through the designated switches. Right? So designated switch handle all the communication from the LAN towards the root bridge. There is no other way to reach root bridge or vCSA without going through the D. That is the understanding. In your case, actually, you can go and talk with the dean, right? I'm not just whatever the way you can communicate. I just took the analogy to understand, right? I know that now people are going and communicating with the VCs directly. It is fair enough because students will not get the solution from the faculty or department or coordinator level. Whatever the way you can approach and correct them. But try to follow the protocol, right? Coordinator is the first point of contact, head, dean, then VC. If you cannot reach whatever the requirement at the your first point of contact, then go to the next level. Likewise, follow the protocol and achieve whatever things you want. These days, actually, people are discussing about the fourth year also. I discussed the situation with the fourth year. So with Vidasun, fourth year is actually, it's okay, but you will be provided with the BTech special degree. So BTech special degree and BTech whatever now you have BTech general degree. I find there is no difference at the end. You have the 4-year degree and you can go to the private sector and say that you have 4-year degree, so you can do much better than those who have 3-year degree. It is obvious. And you can go for foreign country and continue the studies with the 4-year degree. It is also possible, but some cases student race they want to join with the universities, they want to have accreditation with the IESL or IQSSL or CSSL. For that they are looking at the 4-year degree. In that sense, in the public sector involvement, always they map the NVQ pathway with the SLQ framework. There are two frameworks, educational framework, right? Entire for entire Sri Lanka, SLQ, Sri Lanka Quality Framework, SLQF. On the other side, NVQ framework, National Vocational Qualification Framework. So your NVQ 7 is mapped with the SLQF 6, I guess, right? SLQF 6. With the BTech special also, it is not mapped with the SLQF 6, but it is not mapped with the SLQF 7 also. 7 is away from that. So eventually you will be mapped with the NVQ BTech special also mapped with this SLQF. What is the number? Should I analyze it? I will share. I will describe it to you. It is little important as discussions are continuing. This is how it happened. You will get BTech NVQ 7, then BTech special,
Screen එකනම් පේන්නේ නැහැ sir.
right? That is what you expect.
Sir,
But
screen-
when we compare with the two different framework, SLQ framework is there, NVQ framework is here.
සර් ස්ක්‍රීන් එක පේන්නේ
Sorry. Right. Yeah, this is the actually NVQ framework pathway. I just extracted only from NVQ 5. I no other part because that is large image. You can find it in the internet. Somehow you reach the NVQ 7, then special degrees here. Optional 4th year for the selected courses as per the requirement. Even some degrees is compulsory to continue with the first year, some are not. Once someone get that NVQ 7 equal degree, that is your present degree, it is equal to SLQ Q level 5. Right? With that maybe this is official one, not extracted myself. Just extracted myself, but it is from the official document. Then once you have the BTech special degree, the problem is it is not matched with the SLQ L6 because NVQ levels are finished by NVQ 8. NVQ path is finished by NVQ 7, no NVQ 8. So while we are developing the curriculum, I request, this is an official document I shared about my comments. So I emphasize that it is possible in the private sector and foreign studies employment as the performance is significant. Sorry, we have to read from here. Further, if students try to earn the recognition through the 4-year degree, it is possible. Some cases, it is not possible, some other cases. Possible in the private sector and the foreign studies employment as the performance is significant while the 4-year degree is just a self-introductory term. You can introduce yourself as you have this special degree, but if someone want it to show their caliber, in other case, it is not possible in the public sector because such considerations are mapped through mapping of figure 2. As a result, there is no extra recognition for the 4-year degree in the public sector. So what suggested, I am not discouraging. I'm just saying it is important to consider the possibility of give NVQ 8 and to match NVQ 8 with SLQF 6. That might be the solution. Without having such initiative, it is not possible. You will not get the real benefit about the BTech special degrees. Even once we consider the accreditation purpose, they looked into the university, no? Then university then looked into the NVQ. Then they will come up with this, looked into this framework. Then eventually they will understand, although transcripts are mentioned with the SLQ, NVQ, BTech special degrees, eventually it matches with the SLQ level 5. So although you have 4-year degree, it will not be considered as even 4-year for the accreditation purpose. Anyway, that is under the discussion now. We are continuing with the curriculum also. It is in progress in accelerated manner upon the direction of the Vice Chancellor. It is the good side. That's why we are also contributing this discussion. Just while we are continuing the curriculum development, we want to think some alternative way to bring the value. Actual value. So if you are recording my session, please ignore that part, right? If you, when you are sharing, just remove that part because it's not related to the module. Just for your information, I just share, right? Okay, so anyway, I wanted to describe about the root bridge and the designated bridge. Yeah, designated switch or designated bridge. Then we came here. Okay, before that, do you have any question regarding that? That I can answer at this stage. Hope you don't.
No, sir, clear, sir.
As actually, one other thing, this 4-year degree, as far as our present SOR for the University of Vocational Technology considered, you can get into the university. University it is possible, not but lecturer. If you get the 4-year degree, it is the qualification to be shortlisted for the interview, but not for the other university, because when you go for other universities, they will just map again with the SRQF what is this thing to understand about our degree. But here in our recruitment procedure, the BTech special degree is considered, as far as I know, in that sense, because everybody knows we have BTech special. Once implemented, everybody knows BTech is special. So the present arguments in our university, it is possible. But when it comes to the other universities, they will match with the SLQF. So it is arguable. Anyway, things are in the discussion. We'll see what we can do for you guys. So that is the situation. So such situation, actually, to introduce that strategic level things, you have to go and talk with even top management. So it is totally acceptable. So reaching the root bridge directly, right? Not going through the designated bridges in such cases. It's all right. I'm not.
Wait for the program.
Any question? No? Vidasun? Okay, no?
Okay, sir.
Okay. Okay, we will come back to the topic, spanning tree protocol. We are continuing the same topic. How BPDU can contribute for the synchronization or establishing the spanning tree. This is the root bridge thing. This is act as root, then it is the root or root bridge. This is the designated device or designated switch. Then we come into about the port. This is the port, root port. Choose one of its port as root port for each non-root switch. So where the root port is available, root port එක තියෙන්නේ මොකේ කොහෙද? Choose one of its port. One of its port mean we previously discussed about this designated switch. So we pick one port of the designated port as root port for each non-root switch. This thing happen for all the non-root switch. Root bridge එකට අමතරව තියෙන අනිත් switches වල root port එකක් තියෙනවා. This is the interface that gives the best path to the root switch. So that root switch direct provide the root port provides the direction to the root switch. Right? Select ports that are part of the spanning tree. Select ports that are part of the spanning tree. The designated ports. So finally, designated ports are also important. So these are part of the spanning tree. Non-designated ports are blocked. Right? That means we have root port, designated port, and non-designated port. Root port provides direction to the root. Then whatever the contributing ports for the spanning tree other than the root port are designated port. Right? Then the ports which are not contributing for the spanning tree, non-designated port, which are blocked. Root port, designated port, non-designated port. Root port provide the direction to the root. Designated ports, active ports in the spanning tree protocol other than the root port. Non-designated port mean the ports which are not contributing for the spanning tree. Those are the three type of ports. Okay, let's get into the specific case. So in this case, this 1/1, 1/2 is the port number, usual case 0/1, 0/2. Here it is used as 1/1, 1/2, every cases, then port 1 and 2 contributing here, 1 and 2, and 1 and 2 of the each switch. So root bridge finalizing this one is the first thing. Then in this case, actually the cost to this one 19, cost to this one also 19. Same cost. In that case, the particular instance is as far as cost is same, it just one of the available I would say available nodes, right? Available switches, cost is same. In the case of cost is same. So here the cost is 38, right? Just label is used here because we then some other stuff is related to the network infrastructure. As far as cost is label, it's not a problem. Don't think in deep how cost have been appeared. Those are based on the algorithm what we discussed. So those two cases, again, cost is same. So pick one of them. Eventually, this one also just use to reach this one. But yeah, actually, picking one of these is not the case in this time. This space. Cost is same. It is all right. Here also 9. Left side also 19. Right side also 19. But there is no other way to reach them, so just pick both. But for the other side, that means here cos 38, cos 38. In that case, to avoid the circular path, one of the link is dropped or blocked. So this is root bridge, then others will be uh, designated bridge. Then root port is the direction towards the root switch, which is available in the all non-root switch. So in this case, this switch should have the root port. It is this one, label here actually, showing the direction towards the root, showing the direction towards the root. Here also root port is this one, because it is the link for the root. This port 1 introduce the link for the root, right? So every other ports contributing for the active tree are designated port. This is designated port. This is also designated port. Designated port. This one is not contributing for the spanning tree. So this is non-designated port. Root port provide the direction towards the root. Designated port are the active port other than the root port. Active ports other than the root port. So non-designated ports are the blocked one. So that is the complete understand of this diagram. Any question? Did you get? Yeah.
Yes, sir.
Can understand, no?
Yes, sir.
Good, good. Then move forward. This is another situation which is not comprises with any value, but you can find the circular path. In the physical infrastructure, you can find the circular path. Right? Very clear diagram. But to avoid that, we have to block at some paths. So these are the blocked. In that sense, can you label yourself? What would be the root? What would be the designated? What would be the non-designated port? Not be actual implementation, but as following the steps in the algorithm. Can someone pick one? First thing is we have to come up with the root. What is your choice about the root? Which one is the root? Based on that, every other things are determined.
Middle one, sir.
Sorry?
Middle one, sir.
Yeah, it's okay. Anything you can propose, because we don't know exact values here, but we want to understand about the concept. Then others will be, then we have to have idea about the different ports. Each port there is a label, right? In previous case, think about that. What are the labels for the port? Sorry, yeah, labels for the port. Anyway, what are the block one? blocked one are the non-designated port. Or we will finalize the root first, root ports first, right? All the root switch and others are designated switch or root bridge and designated bridge. Keep like this, then it is much more clear. Otherwise, lots of notes. So, what are the root port? Can you show me the root port? This one, because our root bridge is this. This one. Guys, think about this first. How the root bridge were finalized? Sorry, yeah, root bridge finalized based on the algorithm. Pick one. We already finalized our root bridge in our particular diagram. Then all others are designated bridge. That one also we realize. Then how you finalize the root port? The pathway to the root port, those are in the non-designated, designated bridge, not the root bridge. Those are in the non-root bridge, I would say, like the non-root bridge. So root port is here. With that concept, we have the root port here. Where the root port එක තියෙන්නේ මෙතන.
root port
cursor එක තියන්නේ.
මොකක්ද?
ඔය සර් cursor එක තියන්නේ.
This one.
Yes. No.
This one. Huh?
ඔය මැද middle switch එකේ middle switch එකේ තියෙන දෙපැත්තේ. ඕකයි උඩේ.
මේකයි.
No. ඔය එකයි උඩේ.
Okay. So any other comment? One important thing, one clear statement is root port is not in the root bridge. Root port is not in the root bridge. So this is the root bridge. This is the root bridge. I would. Right. This is the root bridge. So root port is not here. Root port is not here.
in the left.
It just introduce you way towards the root. So it is in the designated switch. These are the designated switch. So root ports are there in the designated switch. So what is your understanding?
Left up corner destination bridge,
This one, for this one,
or right or left? Right and left both are. If we consider one is destination port, we can get that port route or left side port route.
so
Cursor you hold this. I
yes,
think
this one,
yes.
yeah, this is the root for that switch. Because one switch has only one root. මොකද එක switch එකට මෙහෙට යන්න කියලා root එකක් දැන්. If you are asking something from me, I am just saying go to the dean. Because I know that once you go to the dean will attend to the matter. If he has no solution, he will direct go to the VC. Then finally, student will reach the VC, but head transfer it to the dean, not to the VC. In the same way, root VC ಗೆ නෑනේ VC ට port VC ගාවට එතකොට already ඇවිල්ලා VC සට already request එක ඇවිල්ලා. එහෙනම් VC ගාව තියෙනවාද VC ට connect වෙන්න කියලා port එකක් ඕනේද VC ගාවට ගියාට පස්සේ? නෑ. VC ගාවට ගියාට පස්සේ VC ට connect වෙන්න කියලා port එකක් ඕනේ නෑ. අනිත් කට්ටිය තමයි VC ට යන්න කියන direction එක දෙන්නේ. එතකොට VC ට යන්න කියන message එක දෙන්නේ මෙයා. මෙතෙන්ට આવොත් VC ට යන්න කියන VC ගාවට යන්න කියන එක මෙතනින් දෙන්නේ. So direction towards the VC is provided by this port. So here also root port. If you understand the concept, am I correct? If I am wrong, just let me know, right? So this one also root port, root port, root port, root port, and root port. Then you got the idea what is the root port. It is the way towards the root. Now all 4 switches has that part. All 4 switches understand way towards the root. Then whatever the ports in the active tree are introduced as the designated port. Whatever the port in the active tree are designated as labeled as designated port. So this is also in the active end. So we will label it as a designated. Is actually designated port. This one also designated because root bridge comprises with all the ports as designated port. No argument. All the ports are designated in the root. Because all the links are actually there can be cases where root is connected with one of this switch 2 times. මේ එක link එක වෙනුවට links දෙකක් තිබ්බොත් non designated වෙන වෙලාවල් තියෙනවා. Because one link is blocked නේ. But in this case all the ports are only connected with the non designated port at once only. So connected with the designated switch only once. එක link එකයිනේ තියෙන්නේ. So all are designated. Right? So other than that, this one also designated. Then what are the remaining? Block port. Block port are labeled as what? Non-designated. Okay, did you get the understand how to label the ports? Spellings are wrong, I will correct, otherwise it is not good. You got idea about the root bridge, designated bridge, root port, designated port, non-designated port. 5 concepts. Eventually you will find out spanning tree. No questions? Oh, full of questions. 2 things can be happening. Can't understand anything or Tenil?
Clear, sir.
Tarinder? Yeah, okay. I think others are also okay. Hasita?
Clear, sir.
Okay, good. So with that understand, we will move forward. Spanning
Sir,
free. Yeah, can.
root එක මේ port දෙකකට වැඩි තියෙන්න බෑද මේ designated port
මොකද?
root bridge එක දෙසිට තියෙන්න බැරි
root bridge එක clear වුණේ නැහැ මට. root bridge එකේ designated port දෙකක් තියෙන බැයිද? ඇයි දැනුත් හතරක් තියෙනවානේ. මේ වෙලාවේදී හතරක් තියෙනවානේ. designate මොකද්ද?
හරි සර් මේ මට මේ උඩ දෙකයි පල්ල දෙකයි පැටලෙලා
හරි okay. So spanning free operation. When the network has stabilized, it has coverage and there is one spanning tree per network. Hope you have that understand. Now network is stabilized, right? With the previous diagram, it is now very much clear. No loops in the network topology, physical topology. There is no any loops. So there is only one tree within the network. So as a result, for every switch network, the following elements exist. One root bridge per network, one root port per non-root bridge, one designated segment, right? One designated port per segment. Segment කියන්නේ එක link එකක්. එක link එකක එක පැත්තක් root වුණ ගමන් අනිත් පැත්ත designated. එක පැත්තක් non designated වුණ ගමන් අනිත් පැත්ත designated. Right? We followed that. Unused non-designated port. Non-designated ports are not used. So those steps you have, those understanding is with you now. Root ports and designated ports are used for forwarding data traffic. Root port and designated ports are used for forwarding the data traffic. Non-designated port discard the data traffic. That means user traffic. These ports are called the blocking or discarding ports. Yeah, these are called the blocking or discarding port. Then the same diagram is here. With that, actually, you can just again visualize the things we discussed here in the previous two slides. Other than that, I cannot find any extra information with this diagram. We'll move forward. Selecting the root bridge. I think same set of slides were repeated here. I think that is the problem. Yeah. Couple of slides are repeating these things. Okay, so let's see. Selecting the root bridge, then there is no extra information with that anyway. Again, just discuss the how root bridge is finalized, right? So yeah, let's move forward. Yeah, this is important. This is about the structure of the Bpdu. So bridge ID consists of a bridge priority that default to 32768 and switch based on the MAC address. That means always the bridge priority is assigned. That priority actually used to finalize which one is the root. Here the default value is 37,668, right? That is the default value. If you just get the switch and from in the simulation environment and looked into the uh, bridge priority, the value is 32,768, right? It range 0 to 65,535. 0 to 65,535. So range is actually a values for the bridge priority. As far as we allocated 2 byte or 16 bits, obviously we can go from 0 to 65,535. That means how many ones? 16 ones. 16 ones for the highest value. 16 zeros are here for lowest value. Eventually it is 0. Default value is 32,768. So that is the bridge priority. The root එකක් තියෙනවා නම් 32,768 කියලා, which is the default. Everyone has 32,768. With that priority, with that same value for the priority, are we assigning priority? Again, once the every switch has the default value, are we giving the priority or not? ඔක්කොටම එක වෙලෙ දැන් you all are around 10 in the class now, 11 in the class. All you have same priority. Maybe let's assume the same as the switch this environment. All you have the value called 32,768, which is the default value, and no one has changed your priority. Then as far as all you have that value, no one will be highlighted, right? But if I assign 50,000 for someone, 50,000 for Tarinda, he is the representative for the batch, then he will get the priority. Then module representative is Vidasun. If I assign 40,000 for him, he will get the second priority. In case Tarinda is not active, shut down, then Vidasun will work as a module representative. Such understand is there. If someone is not willing to accept the responsibility, I may assign 20,000. Then whatsoever, that person will not be assigned as root, because there are many more at the default priority level. Did you understand the point with the priority? You are assigning a value, or switch is assigning a value by default. We can change, we can play with that. Then once we assign the higher value, that switch will get the higher priority. Once we assign the lower value, that will come up with the lower priority. In that case, it will not be assigned with anything. Any question? Did you understand?
Yes, sir.
Yeah, okay, good. Everybody, you're okay, no?
Yes, sir.
Then bridge ID is used to identify each bridge or switch. Bridge ID is used to determine the center of the network in respect span entry protocol known as the road bridge. So center of the network is introduced as the road bridge, not the physically centered. It depends on the transmission media bandwidth or priority level. Likewise, algorithm consider many things. However, once we consider the root, it is the one who coordinate the entire network for that particular instance. It can be changed. It can be changed depending on the environment. One link may be down, then entire network would not be able to reach through that one. So in that case, actually, the logical path or logical topology will be different, but root will not be different. But in case root is down, root is not active, then another root will be somehow find through the same approach through spanning tree algorithm. Right? Then inferior Bpdu. That means specific kind of Bpdu. Let's look into that. By default, Bpdus are sent every 2 seconds, right? Every 2 seconds, Bpdus are sent, shared. When switches first starts up, it assumes it is the root bridge and sends inferior Bpdu. Okay, if someone get into the network, switch get into the network, at the very beginning, no idea about the others. No idea about the other switches in the network. Then switch newcomer assume that it is the root and share the inferior Bpdu. It is the very commonly introduced type of Bpdu. Without having understand about the others, just share it because get to know each other, like sending the apt request, something like that. These Bpdus contain the switch MAC address in both root and sender bridge sender bridge ID. These BPDUs contain the switch MAC address in both the root and sender bridge ID. Yeah, that means in that sense, the difference is both root bridge ID and sender bridge ID related MAC is same. Can you understand? First and third are same because it is the root, and root path cost is also 0. Root path cost is 0 because it is the root. Root again, root and cost and root introduce this BPDU cost from root to root 0. Root bridge ID also this particular one, this switch. At the same time, that one is sending. That one is sending the BPDU as that logic. As per that logic, sender bridge ID is also same MAC, right? Uh, okay, so I think what is the yeah, it just sharing the first part is 32,768 is the bridge priority plus MAC address. Both are sharing with the BPDU. Sending port ID, port number is 30 as per the example. Right, selecting the root bridge. All switches see the bridge ID sent actually with reference to the inferior, right? Now This one is shared by the newly entered switch. All switches see the bridge ID sent now inferior with the inferior one, inferior Bpdu. As a switch receives the Bpdu with lower root bridge ID, it replaces that in the Bpdus that are sent out. Is that lower bridge ID? Yeah, I think based on the MAC address, it just find out the lower or higher. Just MAC address, multiple A's are there. We looked into that, right? Uh, as a switch received the BPDU with the lower root bridge ID, it replaced that in the BPDUs that are sent out. All bridges see these and decide that the bridge with the smaller bridge ID value will be the root bridge. I think yeah. So initial decision as far as priority is same, MAC address is considered for finalizing that root bridge thing. So in this case, in this particular case, MAC address is multiple A's here. So with that, switch receive the BPD with the lowest root bridge ID. That means once root receive the BPDUs and it comprises with the lowest root as a in the root bridge ID section, lowest ID, then it replaces with the when it produce the BPDUs once again or transferring it through the switch, it replaces the present root bridge ID as the newcomers one and reproduce the BPDU through the network. Eventually, the root will be changed, right? All bridges see this and decide that the smallest bridge ID value will be the root bridge simply. So finally, the bridge ID or MAC address, as far as priority is same for all. Bridge ID comprises with the bridge priority and the MAC address. Once the bridge priority value is same for all the switches, then MAC address will be the only the decision maker. So it says the lowest root bridge ID, then lowest the better. In that previous example case, I said 50,000 for Tharinda and 40,000 for Vidasun. So in that case, it should be maybe 10,000 or 500 for Tharinda and 1,000 for Vidasun, something like that, if we consider the lowest. But logic, depending on that way it absorbed to the protocol, you can understand different values. If priority is given for the highest, then we will assign the highest value. Priority is given for the lowest, then we will assign the lowest value as per the situation. Just understand the concept in that sense and look forward what actually happened. Cat is the newly introduced one. At the moment, Cat C, I think they are trying to introduce the situation what initiated when Cat A comes. Let's see. Referring to this diagram, let's see. Anyway, no specific information with this one. With that one, road bridge is this anyway. Yeah, nothing. We'll move forward and see, right? Nothing new with that image. But it might be useful in the future slides. We'll see. Selecting the root bridge, a network administrator may want to influence the decision by setting the switch priority. Network administrator may want to influence, right? As I mentioned, I want to all have same priority. I want Tarinder to be represented. In that case, I influence his number, right? As a network administrator, I am the network administrator, then you are the switch. I change your numbers, priority numbers. Network administrator may want to influence the decision by setting the switch right? Network administrator may want to influence the decision by setting the switch priority to smaller value than the default, which will make the bridge ID smaller. So I will assign 500 for the Tarinder. Smaller is the priority. Then 1000 for the Vidazone. So likewise, just assign different numbers for different person. Then I have some order to execute whatever the instructions I am giving as the root, something like that. I would say no, something like this. That means in the network there are switches in different level. At moment are in the as the lowest bit ID active in the network as a root. Once he is left due to some reason, then Vidazone will appear. Once he is also left, maybe someone else will get that one based on that priority number, right? So if all the priorities are same, then go into the MAC address level to find out what would be the root. Actually, it is the once it is assigned, then again that protocol consider the distance, right? Distance also based on that some path will be activated, some path will not be activated, or some path are blocked. All are activated first, then some are blocked depending on the cost it considered towards the route, right? So this should only be implemented when the traffic flow on the network is well understood. As far as we have better understand about the route, traffic, then we finalize with the priority. For example, in this case, we'll go back to the whatever. In this case, anyone can understand this is in the center, maybe even physically also this can be in the center. Then all the traffic might be go through this. Then I want this to be route without having any argument. What I'm doing, I'm making its priority to very low value. Then that will not be changed. Always that switch will be act as root. Okay. That is the understand. Always just think about the priority assigned for the switch for finalizing the root. So if you want to give root privilege for particular switch, then we should assign the priority at the low level. Then there is a lag. Selecting the root bridge. Yeah, the new stuff are happening from here. You see these things are common. 79, 80, 81, 82. So with this one, you can understand this bit priority. Then this is the MAC. hello time 2 seconds to maximum age 20 second, forward delay to 15 second. So there are some specific information. How we recognize whether this one is root or not. At the moment you know the priority, you know the address. This particular statement, even in the switch, it is displayed. This switch is the root, right? Then in other cases, that statement is not there. Here, priority is there. Not same, no? Just check. 2AD1. Yeah, it is about the root information. Sorry. This is about the root information. This particular switch is this one. Separate one. Its priority also same, but it is not the root. In this case, only with the root bridge, this is actually switch A. This is switch A. This is switch B. Right? In the switch A is root. This bridge is root. Then this information is repeating. This information is repeating. This one and this one same, because within the root ID is MAC address and bridge ID MAC address is same computer, same switch. Sorry, same switch. In this case, root ID one switch, bridge ID another switch. Right? Any question?
No sir. That's what අපි ඔක් කරා මේ අර tab 4 එකේ tab 3 එකේ 4 එකේ තිබිලා මේ උනට ස්පෙලිං එකේ ඔය ස්පෙලිං 3 එක වැඩ කරා ඉතින් එහාට තිබ්බ ටික වැඩ කරේ නැහැ සර් මේ සපෝට් කරන්නේ නැහැ ස්විච් වලට.
ඔව් ලැබ් ෂීට් එකේ ප්‍රශ්නයක් තියෙනවා සපෝට් කරන්නේ නැහැ නේද අන්තිම ටික. මට මතකයි සීනි බැච් එක කරලා. That mean you got the idea, no? Did you do this part again in that lab?
We try to do lab 4, not this.
I supposed to give this work for you guys now. Is it required or not required? For having that understand about the bridge and the other, root and designated switches. You have that idea now? Or you want to continue this?
Last lab we have no theoretical concepts, but now it's I think okay sir. Because we do lab practical previously, but and some basic things, and now I think it is okay.
Okay, actually it is one way of teaching. That is one way of one pedagogical way. That mean flip learning. Flip mean we are giving something it's related to the session beforehand, but it is not actually it's related to flip learning, because flip learning we are just giving this session beforehand and do the practical in the class. Flip, because usually we are teaching and doing the homework. No, teaching and homework is traditional way. Flip mean doing the homework in the class and give the session for you to study beforehand, as a pre-activity. Anyway, due to some reason I have shared that lab also beforehand. Anyway, if you cope up with that thing, it is okay. So shall we do this one in the breakout rooms? Do you have these slides?
Yes, lecture 3 I think.
You have?
Yes, You send us to all things.
Okay, then can you get into the slide number 75? I will introduce the breakout rooms. One other thing, Vidasun, can you share that conference recording? Do you have that one? Because once you share through the Zoom, you will not be charged for the data, and others will also get the copy.
This conference.
මොකද්ද?
මේක ප්‍රැක්ටිකල් එකද?
No. අර ජර්නල් ගැන තිබ්බේ මේ කොන්ෆරන්ස් එකක් ඔය රෙකෝඩ් කරේ.
ඒක ගබයි. අයනකොට
ඒක ඔක්කොමලට මේ ඉම්පෝර්ටන්ට්. ඒකින්ද මෙතන ෂෙයා කරන්න. එතකොට everyone will get the copy. මටත් ඒක අමතක වෙන කලින් මම මතක් කරේ. Meantime, shall we do this activity?
Okay, sir.
Yeah, let's do then. I will introduce. Okay, get ready with that. Next class you can share, right?
Okay.
Okay.
better දාලා මම share කරන්න මේ private දාලා.
මොකද්ද?
මේ YouTube එකේ upload කරලා private දාන්නම් sir. එතකොට ඒක ලේසි.
unpublished link එකක් විදිහට දාන්නකෝ එමුණත් අනිත් කට්ටියත් එක්ක share කරන්න. ඒක හොඳ වෙයි කියලා හිතනවා මම journal article ගැන කට්ටිය දන්නේ. Anyway, I'm going to introduce you into the breakout rooms.